This question given in GATE 2014 session 3 EC paper. The question is, the circuit shown consists of JK flip-flops, each with an active low reset signal. The counter corresponding to this circuit is, so we need to find out a counter realized by this circuit. The information related to JK flip-flops and design of the sequential circuits can be found in this digital circuits course taught by Professor Santanu Chattopadhyaya, Department of Electronics and Electrical Communication Engineering, IIT, Kharagpur. So, before going to discuss about counters, we need to understand truth table for JK flip-flop. What is the operation of JK flip-flop? Here, okay. So here a negative edge JK flip-flop is given. For this JK flip-flop, active low clear input is given. So whenever clear input is logic 0, irrespective of JK inputs, whether JK is logic 1 or logic 0, the output is always 0. When a clear input is 1, at the negative clock transition, if J is 0 and K equals to 0, there is no change in the output of JK flip-flop. Previous value is retained. When J is 0 and K equals to 1, the output value of Q is 0. Similarly, J equals to 1 and K equals to 0, output will be 1. When J is 1, K equals to 1, the output will be complemented. Previous value of JK flip-flop, Q output will be complemented. So this is the truth table of JK flip-flop. So from this information, using this information, we can solve the given problem. So here 3 JK flip-flops are given. So all flip-flop are negative edge trigger flip-flop. JK flip-flop 0 output is connected to clock input of flip-flop 1. Similarly, output of flip-flop 1 is connected to clock input of flip-flop 2. The NAND gate output is connected to clear input of all the flip-flops. That means when the flip-flop, when this clear input is logic 0, all the output states will be logic 0, irrespective of JK inputs. Here all the JK flip-flop inputs are connected to logic 1. That means at every negative clock edge, all these flip-flops output states will be complemented. Suppose if I assume a clock signal like this. Assume this clock signal is applied to the above circuit. So flip-flop 0 Q0 will toggle at every negative clock transition. Initially, I will assume all the outputs are at logic 0. So at the negative clock edge, the flip-flop 0 output Q0 will be toggled. Q1. So for flip-flop 1, Q0 is the clock signal. Initially Q1 is at logic 1. So at the negative clock transition of Q0, the output of Q1 will be toggled. So here negative clock transition, that means output will be toggled. Similarly flip-flop 2, the clock input is Q1. So at the negative clock transition of Q1, the output of Q2 will be toggled. So initially Q2 is at logic 0, so output will be toggled. So in this circuit, for this NAND gate, Q2 is one input and Q0 is other input. That means this output will be logic 0 when Q2 is at logic 1 and Q0 is also at logic 1. Here 0 0 0 and here 1 0 0. I can extend this waveform like this. So at this clock instant, Q2 will be logic 1 and Q0 is also at logic 1. We know that when Q2 is 1 and Q0 equals to 1, a logic 0 is applied to all these flip-flops, makes all the output states is logic 0. That means at this clock, all the outputs are forced to logic 0. Forced to 0. Again what happens? Again Q0 will start toggles at every negative clock transition. Similarly, Q1 will toggle at negative clock transition of Q0. And this will continue. This Q0 is logic 0 and Q1 is logic 1 and Q2 is logic 0. Here Q0 is logic 1 and this is logic 1 and this is logic 0. So at the first clock transition, Q2, Q1, Q0. At the first clock transition, these are the values of Q2, Q1 and Q0. At next clock transition, 0, 1, 0. At the third clock transition, 0, 1, 1. At the fourth clock transition, 1, 0, 0. 1, 0, 0. At the fifth clock transition, all the outputs are forced to 0. So this will be repeated. So here we know that the modulus value of this counter is 5 because it has 5 distinct states. And here at every clock transition we can see that the value of this counter will be incremented by 1. From this we conclude that number of distinct states of this circuit is 5. That means modulus value of this counter is 5 and the values are incrementing. So initially it is 0, 0, 0 and 0, 0, 1 like that. So it is a modulus 5 binary up counter. So option A is right choice.